All right, guys, so let's look at page 4 of the review for integral test on Thursday. So number 14, find the integral from -1 to f of x if f of x equals the following. So again, you guys, this is an old question, so let's look at this. I'm going from -1 to 1, but this thing splits at x equals 0. So I'm going to have two different integrals here. Okay, I'm going to have the integral from -1, 0, and then the integral from 0 to 1. Now, who's who? Well, it says when x is less than 0, the equation is x plus 1. Here I definitely have less than 0, so this is your x plus 1. And then for x greater than or equal to 0, that's this way, right? That's going to be the cosine of pi x. I remember this question is kind of gross, but it's okay. All right, so let's set it up. I have the integral from -1 to 0 of x plus 1. And then plus the integral from 0 to 1 of cosine of pi x dx. Okay? So doing the first one, I'm going to kind of do this in colors. We'll do this one in blue. Okay? The integral of x plus 1, that's going to be x squared over 2 plus the integral of 1 is just x, and it's evaluated from -1 to 0. And let's just go ahead and plug it in. So if I plug in the 0, I'm going to get 0 plus 0, which is 0, and then minus. You guys, if the 0 is on the top, you know how sometimes we just kind of cross them out? If it's on top, do not cross it out because you're going to mess up with the negative sign, okay? Okay, but what I have here, let's go back to this. If I plug in the -1, -1 squared is 1, so that's 1/2. And then minus, and then if I plug in the -1 there, I'm going to get minus a -1, which is really a plus 1. Okay, so what do I have? I have 0 minus 1/2 plus 1, which is 3/2. So 0 minus 3/2 is really -3/2. So that's the first little part. Okay, now let's do the second part. Let's maybe do that one in red. So the integral of the cosine of pi x. Hey, notice there's something besides an x inside the parentheses, so I'm going to have to do u sub here. So for this one, I'm going to say that the u equals the pi x, and then the du is just going to equal pi dx. Okay, so let's rewrite that integral. I have the integral of the cosine of u. Your dx becomes the du, and then I have this extra pi, so I need to multiply by 1 over pi on the outside. Now, plugging these guys in for our boundaries, remember every time you do u sub, you have to change your boundaries. If I put a 1 into here, I'm going to get pi times 1, which is pi. So my upper bound is my upper bound is pi. If I put in the 0 into this x here, I'm going to get pi times 0 is 0. So my lower bound did not change, which is good. Okay, now integrating this, I'm going to have 1 over pi. The integral of cosine of u is sine of u, evaluated from 0 to pi. Okay, if I plug this in, I get 1 over pi times the sine of pi, minus, if I plug in the 0, is going to be the sine of 0. And then this is 1 over pi. You guys, the sine of pi is 0. The sine of 0 is also 0. So this is really 1 over pi times 0, which is just 0. So this guy's 0. So -3/2 plus 0 is -3/2 for your answer. Okay? All right, let's look at number 15. Okay, definitely want to do u sub on this one because I have a funky square root on the bottom. So I'm going to make my u on this one the 1 plus x. That means my du is going to be 1 dx. So doing the substitution, I'm going to get the integral of 1 over the square root of u. And then the dx is going to become my du. I do have a leftover 1, but that does absolutely nothing, right? Now let's change the boundaries. If I plug an 8 into here, 1 plus 8 gives me an upper boundary of 9. If I plug in a 0, 1 plus 0 is 1. Okay, now integrating this, so I have the integral from 1 to 9. I'm going to rewrite this as u to the -1/2 du. And then let's go ahead and add 1 to integrate this. So what am I going to get here? This is going to be the integral from, no more integral because I'm not integrating. Sorry about that. It's going to be u to the -1/2 plus 1 is 1/2. Multiply by the reciprocal, you get a 2, and then I'm evaluating that from 1 to 9. Remember, u to the 1/2 is the same as the square root of u. and then plugging this stuff in, I'm going to have 2 times the square root of 9 minus the square root of 1, just plugging those guys in. So this is really 2 times 3 minus 1, which is 2 times 2, which is 4. So the answer is D. All right, let's look at this guy. Okay, another u sub. What do you guys think the u is going to be this time? Okay, if you picked x cubed, you would be correct. So u is x cubed, which is this little guy there. The du is 3x squared dx. Okay, so now doing substitution, thank goodness there's no boundaries on this one. I'm going to have an e to the u on the bottom, and then this x squared dx is still left over. Well, here it is. That becomes your du, so I have a du here. And then the 3's left over, so I want a 1/3 on the outside. Okay, now integrating this guy. Okay, I should have brought that up to the top first and made it a negative x cubed. It comes out gross. You have to do a double u sub, which you guys have never done. Okay, so I'm going to erase all this and do this a different way. I'm trying to avoid auto deselect. What does that mean? I have no idea. You guys, there's something called like a double u sub where you could do like a v sub. We have never done that, and I want to avoid that. So let me show you another way to do this one. Okay, another way to do this one, I apologize, is to bring this to the top, okay? And so it's going to be x squared e to the negative x cubed dx, okay? Because I need to get rid of that negative there. So let's go ahead and do the u sub again. The u is going to be negative x cubed. Therefore, the du is going to be negative 3x squared dx. And that's how you kind of deal with it, okay? So doing the substitution, I'm going to get the integral of e to the u. And then again, I have this x squared dx left over, and that's this right here. That becomes your du. And this negative 3 becomes a negative 1/3 on the outside. Okay, now the integral of e to the u is just e to the u, and then replace the u with what it was in the first place, which was this negative x cubed. So e to the negative x cubed dx. Nope, plus c. No more dx, my goodness. Okay, so sorry about that. But you guys, sometimes that happens where you're like, ooh, I don't know what to do, and you just got to do it a different way. All right, number 17, this one's the pain. This is the one where you have to do the long division. My gosh, I hope I have room to do this on here, but let's try. Okay, so we're going to do x minus 1 divided into 4x cubed plus 3x squared plus 2x minus 3. Okay, so let's do this. So x goes into 4x cubed. No, I don't want a highlighter. Let's try that again. It goes in there 4x squared times. If you multiply that, you're going to get 4x cubed minus 4x squared. And then you guys remember, you're going to draw the line and change both signs, right? So these cancel out, and you are going to be left with 7x squared plus 2x. And then we're going to do it again. So this time, x goes into 7x squared, 7x times. 7x times x is 7x squared. 7x times negative 1 is negative 7x. But don't forget to draw the line and change both signs. So these cancel out. And then I'm going to have 2x plus 7x, which is 9x. And then I'm going to bring down the minus 3. And then do it one more time. What times x makes 9x? Well, that's going to be 9. So I'm going to have a plus 9. And then 9 times x is 9x. And 9 times negative 1 is negative 9. But then again, I have to draw the line and change both signs. So these cancel. Negative 3 plus 9 is 6. So the remainder is going to be 6 over x minus 1. Okay, so what I'm going to do is rewrite this integral. So I have the integral of 4x squared plus 7x plus 9 plus 6 over x minus 1 dx. Now notice there's the easy part of the integral, which is just the polynomial, and then this guy right here is going to be a little bit harder, so I'm going to separate it, okay? So let's integrate that first part. So this is going to be 4x cubed over 3 plus 7x squared over 2 plus 9x. And then here, I can pull the 6 out, so it's 6 integral of 1 over x minus 1 dx. And sadly, that last part, you guys, is a u sub. I'm going to make this my u. So let's do that on the side. So the u is going to be the x minus 1. The du is going to be 1 dx. So when I do this, I'm going to get plus 6 integral of 1 over u. The dx becomes the du. And that left over is a 1. That doesn't really do anything. And you guys, we know that the integral of 1 over u is the ln of the absolute value of u. And then plugging in the x, this is going to be the ln of absolute value of x minus 1. Okay, so what is the final answer for 17a? I don't even know where to write it, but I'm just going to write it right here. So the final answer is 4x cubed over 3 plus 7x squared over 2 plus 9x plus the ln of, I forgot my 6, dang it, hang on a second, plus, don't forget the 6 there, 6 ln of absolute value of x minus 1 plus c. Gosh, that was awful. Let's hope B is a little bit easier than that. Okay, so again, I'm going to do long division here. So let's go ahead and do that. So I have 3x plus 4 divided into 6x squared plus 8x plus 7. So I need to find out, what do I multiply 3x by to get 6x squared? That is going to be 2x. 2x times 3x is 6x squared. 2x times 4 is 8x. And then if I draw the line and change both signs, oh my gosh, they both cancel out. That's okay. And then I just have a remainder of 7, right? The 7 is the last thing that's left over. 3x does not go into 7. So you guys, it's 2x plus the remainder of 7 over what you divided by in the first place. Okay, so what do we do now? Let's rewrite the integral. So this is going to be the integral of 2x plus 7 over 3x plus 4 dx. Again, I have an easy integral in the beginning, but then a harder one at the end, so I'm going to go ahead and separate them. Now let's go and integrate this. The integral of 2x is 2x squared over 2, which is really just x squared, right? And then I have plus, let's pull the 7 out. So 7 integral of 1 over 3x plus 4 dx. And then on this guy, I need to do u sub again. So my u is going to be that bottom. So let's go ahead and do it here. If the u is 3x plus 4, that means my du is 3 dx. So if I do the substitution, I'm going to get plus 7 integral of 1 over u. The dx becomes the du. And then there's this leftover 3, which means I need to multiply by 1/3 on the outside or just divide by 3, same thing, right? So what's my final answer here? This is going to be x squared plus 7/3. The integral of 1 over u is the ln of absolute value of plus c. And then changing the u back to what it was in the first place. So 7/3 ln of absolute value of 3x plus 4 plus c. Okay? All right, let's see what we've got here. Now, you guys, number 18, you actually don't know how to do this one yet, but you will tomorrow. So let's go ahead and do it anyways. So this is an absolute value function. I'm going to pretend like you do know how to do it. So we need to split this integral where the absolute value equals 0. So where does x plus 2 equal 0 at? That equals 0 at x equals -2. So that's where I'm going to split this integral. I'm going from -3 to 1, and I'm splitting this integral at -2. So I'm going to go integral from -3 to -2 of x plus 2. Plus the integral of -2, sorry, not -3, -2 to 1 of x plus 2, okay? And then remember at the end, we're going to be taking the absolute value of both of these values, okay? Again, if this is weird to you, it's because you haven't seen it yet. Okay, now let's integrate the first one. The integral of x plus 2 is x squared over 2 plus 2x evaluated from -3 to -2 plus, and this one is also an x squared over 2 plus 2x evaluated from -2 to 1. Now, you guys, I'm going to color code this. I'm going to make the first one red. So I'm going to make this guy right here red. Let's do that first. We'll do that all the way like over here somewhere because there's no room. Just go up here. Okay, so plugging in, this is going to be a top minus a bottom. Do I have enough room to do the blue? No, I don't, but whatever, it's okay. If I plug the -2 into the top, -2 squared is 4. 4 over 2 is 2. And then if I plug in a -2, 2 times -2 is -4, so it's 2 minus 4. And then if I plug in the -3 squared, that's 9 over 2. And 2 times -3 is -6. Okay, now let's figure out what this is. 2 minus 4 is -2 minus, and then 9 over 2, I'm going to distribute that and go plus 6. And then -2 plus 6, that's 4 minus 9 over 2. So this is really 8 over 2 minus 9 over 2, which is -1 over 2. But I have to take its absolute value, so the red part is really just 1/2. Okay, now I'm going to do another part. I'm going to call it the blue part. So I'm going to make this the blue part. Okay, I'm going to do that on the side here. So I'm going to do another top minus bottom for the blue part. If I plug in the 1 into here, I'm going to have 1/2 plus 2. If I plug in the -2 into here, that's again 4 over 2 is 2, and this is -4. Okay, so you guys, this is 1/2 plus 2 minus 2 minus 4 is -2, which is really going to turn into a plus 2. So this is 1/2 plus 4. So that's going to be 1 over 2 plus 8 over 2, which is going to be 9 over 2. And since that's positive already, I don't need to take the absolute value of it. So here's my two different values. I need to add them together. So 1/2 plus 9/2 is 10/2, which is 5. All right. Okay, and then number 19 for the last one for today. So I need to do u sub on this guy. So the u is going to be my 2x plus 3. My du is just going to be a 2dx. So replacing this, I'm going to get the integral of the sine of u. The dx becomes the du, but I have a leftover 2, so I have to multiply by 1/2. Now, what's the integral of sine? That's negative cosine of u. And then just putting those together, it's like -1/2 the cosine. The u was the 2x plus 3. And then I have my plus c at the end. All right, so there's page 4. I'll see you guys tomorrow. Bye. Whoops, it's not what I meant to do.